Let's take a look at some more reactions of acid chlorides. We saw at the very end of the last video that we can just treat an acid chloride with water and we'll get a carboxylic acid out. No catalyst required because acid chlorides are so reactive we have a very good leaving group ready to go. We can take an acid chloride and react it with an alcohol as well. And in the same sort of mechanism, nucleophilic attack, loss of a leaving group, just generic, as if it were a base catalyzed mechanism, although we will have a deprotonation at the end, we'll have an ester formed as a result. We'll also be producing HCl in both of these. If we want this reaction to work more efficiently, because HCl as a strong acid can be problematic to other functional groups present in your R group, whatever that happens to be. The rest of your molecule can be acid sensitive. So if we need to remove it again, we'll use pyridine, which we'll often abbreviate as PY. And that pyridine removes the HCl. I'll just write that because I've said it a few times, but I don't think I've written it. It removes HCl rapidly from the solution. So the pyridine is there to get rid of the HCl so it cannot go and react with other things, because as a strong acid, it's pretty reactive. It can go find something if it's not removed. So the pyridine is there to remove it from the solution. All right, we can also we can't hydrolyze, but we can use amines as well to form amides. If we take an acid chloride and react it with an amine, how about we use dimethylamine? What's important here is that in the first step, in this reaction, we're going to end up substituting in our amine. We produce an HCl, and while amides themselves are not basic, amines are, and so another molecule of this amine present will react with that HCl, producing the ammonium version of this and the chloride ion. NH. So we end up with this extra byproduct. And that, as we see, the ammonium there has no lone pair. It's no longer nucleophilic, right? So in lieu of putting pyridine here, because we don't want to have all these different amines in there, the pKa's of the pyridine and of the amine would be similar. So you're still going to not really guarantee that you're getting rid of all of the HCl. So what we do instead is we use two equivalents. And in doing that, we'll have one equivalent to do the substitution and one equivalent to get rid of the HCl byproduct. And so that works that way. So if you want to make an amide, whatever it may be, why don't we use this molecule here? You want to use two equivalents of it. And in doing so, you will end up getting your amide, and you'll make your protonated amide with the HCl, which I'm not going to draw. But that's your byproduct. So if you want your reaction to go to completion, you've got to use two equivalents. All right, so that's with amines. We can also turn acid chlorides into we can make them into anhydrides. That's not a functional group we've seen yet, but here we go. Because they are so reactive, if we take a carboxylate, the carboxylate is nucleophilic enough that it can go ahead and attack, kicking out the chlorine like with all of our other mechanisms, and we will make what's called an anhydride. This is not a molecule we've seen yet, but it's one we will see next. Anhydride. So we're going to make an anhydride there using that, and we're going to produce NaCl, which is a fantastic byproduct, right? So we're good there. So we're going to make an anhydride if we use a carboxylate. So carboxylates, as we know, are formed from acid-base reactions with acids, carboxylic acids. You'd take your sodium hydroxide, react it with your carboxylic acid, now you've got that carboxylate. And you can react that with your acyl chloride, producing what's called an anhydride. That's something we're going to look at next. That's our next functional group of interest in these derivatives. All right, so we can go ahead and take a look at the rest here. Let's summarize. So we can hydrolyze them, turn them into carboxylic acids by using water. Again, a little bit of pyridine to help out. We can use an alcohol to make an ester. We can use two equivalents of an amine to make an amide. We can use a carboxylate to make an anhydride. And so we have now a way of getting from acyl chloride to any other carboxylic acid derivative, except nitriles. We'll talk about those later. But we can do other things too. For example, what if we wanted to make an aldehyde instead? What if we wanted to, use a Grignard on this? Because this is an electrophile. What would happen in those circumstances? Well, to find out, you'll have to watch the next video.